Hello guys, this is episode 7 of System Design 100 and you're watching Stateless Web Tier or what exactly is state. Now, before talking about state, when talking about state, I'll, I'll, I'll try to explain you by doing a comparison. So there are two types of web tiers, the web servers implementation we do in whenever we're designing a system. One is stateful architecture, and other is stateless architecture. Now, both of these have their own uses, and the main difference I want to the main difference that I think between these two type of architectures is that the number of users or the scale of application you're trying to build. For example, if you have if you have let me first explain what these two are. So what happens in stateful architecture? If you have, for example, three users, right? User A, user B, and user C, and you have three servers B and server A, B, and C. Okay. So in what happens in stateful architecture, whenever a user tries to connect to a server, B connect to a server, C connect to a server, all the data related to user A, temporary data. I'm not talking about login data. Please remember that login data is persistent data which is stored in persistent databases. This is temporary data. This is a temporary data that the user creates. For example, you remember Amazon, right? So when you visit Amazon's website, and even though you're not logged in, you can add something in cart, and even though if you go outside the website, you refresh the page and you come back, that same item will still added in the cart. It's not removed from the cart, even though if you go out or you refresh the page, right? So that is equivalent to that the website is maintaining the data somewhere in the web servers, right, against the some identity that your computer or your IP address is holding. There are multiple ways for the servers to identify you when you visit a website. Okay. So how it does that? Generally, in stateful architecture, the data is stored within the server itself. Servers are computers and they have their internal storage. So the temporary user data is stored in the server itself. So for example, user A connects to server A, its temporary data will be stored in A. B's temporary data will be stored in B. C's temporary data will be stored in C. So this is basically the stateful architecture in which the state of the particular user is stored in the particular server it visits. Generally, in very small websites, in which doesn't expect too many users, this is a very good enough design, and this works for extent of your application. For example, if you are getting 1,000 requests per day or 10,000 requests per day, this works very fine because servers are able to handle this much by themselves. Now, the issue comes when you are getting a lot of requests. For example, 100,000 and a million requests per day. What will happen, for example, sometime that when user A is not there, other users will try to get server A, and so server A will get very busy. It almost 80-90% CPU is utilized. So when user A will try to visit the server A at that time, he will not able to because the server is very much loaded. So user A's request will be routed to server B. But unfortunately, all of the session data of users A was stored in server A itself, right? So when users A will user A will try to visit will be routed to server B, he'll either face a authentication request or he'll get a totally fresh server without whatever data he has stored, temporary data he has stored in that website. So like not a good experience for user A. Similarly, for user B, it can happen that user B can be routed to user C in case server B is a little loaded up due to very high throughput, very high number of traffic. So this architecture can work in an environment when you do not expect much visitors per day, or you do not have a burst of traffic coming into your systems. So this particular architecture works very fine in that part. But when you expect high number of users or high number of traffic coming into your system, this stateful architecture tends to fail only. So against this, we have something called a stateless architecture, in which what we have a independent uh, web tier from the user data. What was happening in stateful tier was that the user data was being stored in the servers only. But instead of that, in stateless architecture, we create a persistent data that is separate from these servers. And it's a database itself, and it can be any database. It can be in memory or SQL or relational. Generally, we use relational databases because this database can also scale very easily. Relational databases are easy to scale as compared to other databases. Okay, so now we are storing user data here. Okay, and we are routing, pulling data from here, and users are coming like here. Okay, now for example, now user A can be routed to any of these servers. Doesn't matter what load it has and which server has which server is it came to last time, because the session data is stored being in a separate database. Even though user A visits this server, is routed to this server will pick the session data from here, and user A will get the same experience. Similarly for this server and this server as well. So our sticky server issue is resolved. That user needs not to be routed to the same server every time. Okay. Second issue was the second issue that was in the stateful architecture was that scaling. Okay, now that for example, even though in the same situation you see, we are having all these servers. We have users A, user B, user C trying to visit the website, but all three servers are loaded. In whenever right, we have something called horizontal scaling, in which we can add more servers. I'll add another server because these three servers are busy. But again, the same issue, right? User A's data was stored in this server itself, which is now busy. So even though user A, user B, or user C are routed to this server, they will again have authentication issues, or they will not be able to see the data that they have stored, right? Again, but in this case, again, this issue is resolved, right? Doesn't matter how many servers get busy or how many servers are too much loaded. I can add as much servers as I want, and I'll add this database as an endpoint. So doesn't matter if user A is routed to this or this server, he will always be able to see his data because the data is stored externally in a external database. Okay, so this is a difference between a stateful architecture and stateless architecture. Stateless architecture is not always the best solution, but definitely it's definitely considered when you are dealing with a very large amount of users, in which you expect your servers to be busy, and in which you do not want a sticky string generated between your user and a web server. So everything is very loosely coupled here. User A can be routed to any web server. Any web server can access the data, session data of any user. So it's a very loosely coupled system and works very well in very large, where we expect very large amount of traffic. It's not like that stateful architecture it is not useful. Definitely, adding some this kind of complexity in your system, definitely makes it very difficult to handle or very difficult to maintain. So definitely this adds more to the complexity of the system. This is not recommended until you're dealing with very large amount of data. This works very fine until an extent. So if you're dealing with very small amount of users, or your website doesn't expect too many visitors or too many burst traffic at a particular time, then this particular architecture is perfectly fine. So yeah, I guess this was it. I don't think I have left anything. This was episode 7. Thank you very much.